Welcome to our 8th lecture in Computer Programming 2. In this lecture, we are going to take a look at what good design is in programming, and we're going to throw out some things that we knew before and look at some new things. So this is the important one. This, and probably it's going to take about 2 or 3 recordings to get through the whole thing, but this is the lecture where either you get it or you don't get it. So, I hope you're ready. As a matter of fact, why don't you hit pause right now and go get a cup of coffee or a Diet Coke or whatever you choose, just to make sure you're ready. Tell everybody to take a nap, leave you alone for a few minutes, because this one's going to be important. Before we get started, one thing I forgot to mention in a previous lecture is that I have posted a presentation on inheritance and polymorphism, which is the last few lectures we covered. And this goes through in good detail a lot of the things that I talked about. As a matter of fact, most of these slides are animated. And so this is kind of good to self-study. So even before you review this lecture, I recommend that maybe you take a look at this presentation. It's about 17 slides, but as I mentioned, there's a lot of animation in it. You can probably go through it relatively quickly. This is available under course documents. So take a moment, grab this lecture or grab this presentation and review it. And also make sure you're in an attentive and distraction-free position as we go through this problem statement. So I have under assignments this pre-assignment, and this isn't for a grade, it's just for you to think about. But here is a case study, and this is going to take us out of the whole vehicle thing we've been working in for so long. Here's a case study. Think about the different things that an insurance company does. Okay, an individual takes out insurance to protect against an unforeseen hazard. So in this case, an individual is paying an insurance company an amount of money at a regular interval. And upon one event happening, maybe the person's death or maybe a house fire, the insurance company will pay out a lump sum. So the individual is paying in, say, on a monthly basis, okay, in anticipation that at some point there might be a lump sum payment in return. That's what we'll call typical insurance, okay? In our example, we'll call it life insurance, okay? We'll use life insurance in our example. Now, a lot of insurance companies anymore consider themselves financial services companies. And one thing that can happen when you retire is that you might get a lump sum payout from your employer or from a pension plan. And you want that money to last. So you can invest it in an annuity, which a lot of insurance companies offer. And with an annuity, you make a lump sum payment up front, or some event happens which triggers a lump sum payment, and then you receive payments for a specified amount of time, or you can receive payments indefinitely, which is called a perpetuity. Think about the lottery. They always say, you could win $17 million, but that's paid over 30 years. That's an annuity. On the other hand, they would give you a lesser amount if you accept it up front, and that's basically the time value of money. Now, we can say that an insurance company is going to pay out its annuity payments once a month. So what does this have in common with life insurance? It's a monthly event, okay? Life insurance sends out bills once a month, and annuity is going to send out checks once a month. Finally, insurance companies have employees, and employees get paid, say, once a month. Okay, so this might tender an ACH deposit to the employee's bank account. So what does that have in common with life insurance or annuity? Not much, but it is a monthly thing. It is something that happens monthly. So we need to design a program that will model this. We need to design a program that's going to be able to read in a set of files. And I'll show you what these files look like. The files are going to have the word annuity, employee, or life insurance. Ignore mutual fund for the moment. It's going to have the word describing what it is, and then it's going to have an underscore. And then it's going to have a number that represents either the customer or the employee. So what our job is going to be is to write a program that can receive these in any order. Okay, open them up, and we see we'll have some information in here. Open them up and then process them. In other words, if it's an annuity, send a check. Now, of course, our program won't actually send a check. We'll just do a system.out.println that says sending a check. And it won't actually pay anybody. We'll just do a system.out.println. But that's the idea. So employee, okay, we have some employee information, and we have first name, last name, and then a payroll amount, the bank, the routing and transit number, and the account number. So notice that all employee files are the same format, but they're a different format than the annuity files. All the annuity files are the same format, that is first name, last name, payment amount, but they're different. It's a different format than the employee file. Then we have life insurance. Okay, life insurance is again all the life insurance files will be the same format, but that format will be different than the employee and the annuity format. Okay, so those are the rules, and we also have one more rule, and that is we cannot use any conditional statement. We cannot use an if test. No if tests allowed. Okay, so these files are going to end up in a directory. We can read from this directory. We can open the file, and we can read the data out of the file. We have to determine what type of file it is. We have to parse the information in the file. If life insurance, we send a bill. If annuity, we send a check. If an employee, we do an ACH settlement with the employee's bank account. But we cannot use an if test. We cannot use a case switch statement or any other conditional. Think about that restriction and how you might solve that puzzle. That kind of gives us an interesting trick, but what we're going to find is that many times limiting the number of if tests we do and finding a better way to do it many times can hold our hand and give us a better way to do things. There are certain things that we know are good design in Java, and we know, for example, that using the Java Bean standard with encapsulation is good design, using getters and setters. We know it's good to separate business logic and user interface. One other thing we're going to find is good design is using patterns. Under our course slides, this is object-oriented design applied. And these are the tools we are going to use to solve that problem I just mentioned. Reading in files in a random order, being able to process them, and not use an if test. Okay? So, things that we want to avoid, we don't like casting. We don't like instance of. Okay, we don't like those. Let's take a look at object-oriented design applied. Boycott if tests and conditionals. Use design patterns for optimal design and flexibility. This is a presentation that I gave in front of the Cincinnati Java Users Group, and I've used it at the university many times. So this is what we're going to go through today. A couple of quotes that I heard. I had one time back around 2000, I took a training course from Sun Microsystems, who then basically owned Java, and they sent one of their best instructors down. And I was pretty new to Java programming at the time, to be honest with you. And he said two things that absolutely blew me away. One is, if you're not using interfaces, you're only using half of Java's potential. Like you might be thinking right now, you might be confused about what an interface is because we just covered it in our last couple of lectures. We just started talking about what an interface is. We haven't gotten into great depth, and you might think it's just a waste of time because you have this data type and all it has is method signatures, but not the actual implementation of those method signatures. And again, I remind you that variable type and object type can be different as long as object type is a subclass of the variable type or the object type implements the interface of the variable type. So in other words, a variable can be an interface. A variable tells us what methods we're allowed to call. An object tells us what behavior we'll get when we call those methods. And we'll see a real practical example of that in our exercise today. The other quote, you can judge how well an object-oriented program is by how few if tests it uses. So, fewer if tests equals better design. These two quotes blew me away because number one, I was not using interfaces. Number two, my programs were loaded full of if tests. And I knew he was right, but I didn't know why. I didn't know how. I knew he had a point, and I hadn't figured out yet what it was. About 9 months later, it all dawned on me what it was. And that's what I'm going to show you today, both the use of interfaces and elimination of if tests. Okay, this goes on to tell us a little bit more about the problem that we're going to work on today. And we're going to attack this problem using something called design patterns. So what is a design pattern? A design pattern is a programming strategy that's used to solve different problems. Typically what will happen is we will look at programs that have been written and see what they have in common. And these techniques that they have in common we'll call design patterns. There was a book written in 1995 that cataloged a lot of these design patterns. It was written by 4 different people, and it's been known now as the Gang of Four book. In a lot of times, it's kind of considered the holy grail for design patterns. So, why design patterns? What we will do is we will give them this information. We'll give them a name, okay, so that we can refer to them. The command pattern, the factory pattern. We'll have an example problem and how it would solve it, and then any consequences that happen from using this design pattern to solve this problem. Okay? So, one nice thing about design patterns is that it's not specific to a problem, but because it has a name, and developers will know that name, a lot of times you can ask a developer, how does this work? And the developer might say, well, I used a combination of the factory pattern and the command pattern. And based on that alone, you as another developer will understand a lot about the architecture underneath because you might have used the command and the factory pattern somewhere else. These two are two of my favorite patterns. And they're ones that I've used many times in different jobs in my career. And typically, when I do a technical interview, I will ask the candidate, what is your favorite design pattern? And if the candidate says, well, I don't really use design patterns, then I'm going to, then I'm going to start thinking this might not be a good fit. If the candidate can describe a pattern very well and how he or she would use it, then I automatically say, okay, this is somebody I want to talk to more. This might be somebody who's a good fit. Okay, so it's a common language used across all of programming. Now, there used to be a website called, by the way, here's the Gang of Four book. It's called Design Patterns, Elements of Reusable Software. Very good book. There used to be a website called Pattern Depot, and I say used to be because that was 10 years ago. I don't know if it's still around. But it did a really good job of describing a lot of these patterns. And what's interesting is I really like the way it categorized the stages in the learning of patterns. Okay? There are 3 stages that they say it takes to learn design patterns. One is acceptance. Realize that patterns are important. Okay? Recognition. Realize that you need to study patterns to know how to use them. And then internalization. Reach the aha factor where thinking in patterns is just something that's automatic. It takes a long time to get there. I don't expect internalization to happen this quarter. I don't even expect it to happen this year. That takes a long time. I would like everybody to be at the acceptance level by the end of this lecture, or this series of lectures. By the end of the quarter, it would be nice to be at the recognition level. This is a long learning process. It isn't something that we can just write in a book and have it done. And the example we're going to use today is going to demonstrate 2 patterns and we'll get to see the magic that happens when they work together. Now, there are three categories of patterns that are used at Pattern Depot. One is creational patterns, patterns that create objects. You've already used one of these. We used the factory pattern in your driver class. Remember? We had that create car method. This is a create pattern. It is creating objects based on a type. Okay? And we're going to use that again today. A factory pattern, a creational pattern. Another pattern is the structural pattern that talks about how objects are aligned together. We're not going to use one of those. We are going to use a behavioral pattern, though, which talks about how objects interact with each other. So, three categories of patterns. Don't confuse that with 3 stages in learning patterns. These are both going to be quiz questions. I guarantee it because they're in the pool. So you might want to think of those as quiz question suggestions. Just be sure when you take the quiz, you don't confuse 3 stages in learning patterns versus 3 categories of patterns. They are both questions in the quiz pool. So if you get one, make sure you're thinking, wait, is this asking for the categories of patterns, or is this asking for the stages in learning patterns? Okay, creational pattern. We already know about the factory pattern, which is what we're going to look at today. The new pattern is the command pattern, which is absolutely one of my favorite of all times. And it is a 100% wonderful way to show what polymorphism is and how polymorphism can be used. It also shows how we can um, sorry, lost my train of thought there. Polymorph also shows interfaces. It also shows a good use of interfaces. Okay, so let's go back to our problem statement. Okay, our problem statement is we have to somehow deal with these different files. And as I mentioned, we're going to deal with annuity, employee, and life insurance now. We don't know how many are going to be in our directory. We don't know what order they're going to come in. All we know is that they're going to exist. We're going to start a new program, and the first thing we need to think is, how are we going to organize the classes that are going to do this processing? Think about that. What would a class diagram look like? How many classes would you have on there? What would the classes be named? Think about that for a minute. If you're thinking I'd put it all in one class, I'm very worried. That's not the idea. That's not what we want to do. So what I'm going to do now is I'm going to make a new NetBeans project. Okay, file, well, let's see, I could just use the little guy here. Okay, and we're going to call this monthly, or let's call it batch processor. Now, the rules still apply. Even though we're simply reading data without a user interface, the same rules apply that always have applied. We need to keep our user interface and our business logic separate. We need to have Java beans that are properly encapsulated. All of those good design rules still apply. This is going to be our main program, which is our user interface. Even though there is no user interface, this is what's going to be looking at the directory, reading files, so on and so forth. So I'm going to call this class monthly runner. Okay, just like driver or banker. This ends in ER, indicates it's doing some action. This is the thing that's interacting with the file system. And I choose finish. Okay, as soon as I do that, I get the batch processor project, and I can click on files. Under batch processor, I can right click and say new and other. We'll make a new folder. And okay, let's see, we're going to say other, and with any luck folder, there we go. And we'll say, what did I call it in the zip file? We'll keep it the same. Input data, that's fine. Input data and finish. And now what we're going to do, I'll be interested to see if this works as a drag and drop. Now what we're going to do is we're going to take the data from the zip file, except for mutual fund, we'll pick that up later, and we'll drag it, oh, very nice, looks like it might work, and drop it under input data, or maybe we won't. Let's see if I can copy and paste it. Copy and paste. There we go, we got it. So our job is to process this directory structure. And we have our monthly runner, and now we really need to start thinking about what our class diagram is going to look like before we go crazy. Okay, so let me give you a little hint. If we're thinking about Java beans and encapsulation, what data are we going to want to process? What data are we going to want to store? For an annuity, Phil Smith, and a payment amount. So first name, last name, payment amount. First name, last name, payment amount. First name, last name, payment amount. For an employee, first name, last name, payroll amount, bank, routing and transit number, and account number. For life insurance, first name, last name, payment amount, and life insurance type, term or whole life. So term means it expires after a certain number of years, is no longer is valid. Whole life means it's valid for your entire life. So these are the attributes that we wish to store. So we might start thinking, okay, I see, we're going to make three classes, one for annuity, one for employee, one for life insurance. If you're thinking down that path, you're on the right approach. Now let's see, is there a superclass we can make? Is there anything that these all three have in common? Well, that's tricky. Annuity and life insurance, we could say they're both customers. Annuity is a customer. Life insurance is a customer. Can we say that about employee? Not necessarily. Well, okay, we do know they all have to be processed monthly, but can we say annuity is a monthly process, employee is a monthly process? That's where things get a little bit tricky. And when things get tricky, we need to say, well, maybe this is not an is a relationship. Maybe there's not a common superclass, but maybe there's another way we can associate these three classes together. And what would that way be? Think about Prius and Insight from our last lecture. How did we associate those two together? We associated those two together with an interface. So what if we made a class diagram that looks like this? Okay, remember, a dashed line means something implements an interface. Dashed line with an arrow. A solid line with an arrow means extends a class. A solid line with no arrow means uses a. So in this class diagram, we have a monthly runner with a run method. We have a class called employee, life insurance, and annuity. Each of these implements the interface monthly item, which offers a process method. Life insurance and annuity are both customers, so they extend a class called customer. Now, employee, we cannot say an employee is a customer, so there is no relationship there. But notice that while life insurance and annuity are both customers, we're able to tie together employee, life insurance, and annuity by giving them a common interface. That interface has a method called process. Okay? And by having it has a method signature called process. By having that method signature, all classes that implement that interface must give an implementation of that method. Okay, so there we have it. So let's start putting this together. I'm going to go back to NetBeans and I'm going to go back to Batch Processor. I'm going to right click and I'm going to say New Java Interface. Okay, and this Java interface I'm going to call Monthly Item. Okay, and remember this is representing our data. Monthly Item, because this is an interface, notice it's an interface, I'll say public void process string data. So we'll pass data to it in a string form, and I'll say process the data for the specified monthly item. Okay, so far so good? Okay, let's start making some of those classes that implement the interface then. I right-click, say New Java Class, Employee, and finish. Public class employee implements monthly item, okay? And we get a red line, which is going to tell us, let me expand what we can see on our monitor here. We get a red line and a light bulb. So I click Implement Abstract Methods. Okay, we'll come back to this process method in a moment. We'll come back to this in a moment. But right now what I do want to do is I want to set up all the attributes for my employee. So private string first name, private string last name, private double payroll amount, private string bank name, private string routing transit, private string account number. Okay, there we go. Right click, refactor, and encapsulate fields. Select all and refactor. So now we have our employee set up. We still need to decide what to put in this process method, but we at least have a Java bean or a plain old Java object or a DTO, they all pretty much mean the same thing, that represents an employee. So I save, and there we go. Okay, now what I'll do is under batch processor, I'm going to say new Java class. Let's go ahead and make our customer superclass. Okay, customer, we know we'll have protected string first name, protected string last name. That'll cover us for now. I save, I right click, refactor, encapsulate fields, select all, refactor. Note that we're not implementing monthly item at this level, so we don't need that process method. Okay, and again, remember back to our class diagram. We've made our monthly item. We started our monthly runner. We have more work to do there. We have our employee. We have our customer. Now we need life insurance and annuity. Life insurance will have a bill amount. Annuity will have a payment amount. We're currently working on getting our program to look like this class diagram. Okay, so I right click. Let's do a new Java class, and we'll say life insurance. Okay, and finish. Now remember, we want to extend the customer class, extends with an S, customer, and implement monthly runner, or monthly item. Okay, remember we can extend only one class, but we can implement as many interfaces as we want. Okay, implements, sorry, should be implements. We get a red line because we're not implementing all the methods from monthly items, so I go ahead and click and we get our process, okay? And we'll fill out the implementation for that in just a moment. But right now, we're going to say private, let's see, double bill amount. Okay, the amount we want to bill. Right click, refactor, encapsulate fields, select all, and refactor. There we go. So we get our getter and setter for bill amount. Okay, last class to make now. Right click, new Java class. Let's make this our annuity. Remember, annuity is something that pays out periodically. It usually starts with some kind of lump sum payment. Okay, annuity extends customer, which is going to give us the first name and last name fields, and implements monthly item. Okay, and then we save. Okay, we know we have to click the light bulb, and that will give us our process method. Okay, and then we'll say private double payment amount. Okay, right click, refactor, encapsulate fields, select all, and refactor. Okay, and I just remembered I left one off of life insurance. I also wanted to say private string policy type. Okay, right click, refactor, encapsulate fields, select all, refactor, and save all. So we have annuity, customer, employee, life insurance, monthly item, monthly runner. And that should match up pretty closely with this class diagram. Take a look and study that. Notice what implements an interface, what extends a class, okay? Remember, monthly runner is our user is what's going to actually do the interaction, the input and output of data. It's going to use these other classes to help it do that. Okay, so study that for a moment, and then we'll get to monthly runner. Okay, monthly runner. Well, let's see. We used to have a prompt user method that we used a lot when we did our driver and our banker. We're not going to have any user input and output, but what we can do is we can have a run method. So I'm going to say private static void run, okay? Open curly, close curly, and we're going to call this from our main method, run, like so. Okay, now here's where a lot of the real thought process comes in. So what we want to do is open a directory, read the contents, and process them. Okay, so we're going to need some way to open a directory. What we can do is we can use the class called file. We saw this briefly last quarter when we were looking at processing cars. File, input data equals new file, input data. Well, it's named file. In this case, it actually represents a directory. Now, file is a class we need to import, so I click the light bulb, add import. There we go. Okay, so I'll say get a reference to the directory that holds our data files. Okay, and now let's see. Input data dot one moment, please. List files. List files will tell us what files are inside this directory. So I'm going to click on List Files. Okay, and I'm going to say File, open and close square bracket, all files equals input data list files. So I'll say get a list of all files in this directory. Okay. Now what I want to do is we're going to assume that every file in there is a file that I can process. So now I'll say iterate over the files and process them. Okay, so I wonder if it'll let me do a for each. I suppose we could give it a try. There we go, perfect. So what this is going to do now, we'll say data file. What this is going to do, this for each loop is going to iterate over every file in the directory called input data. And remember, input data is the name of the directory where I placed these files. Okay, easy enough. So now I'm going to say scanner scan file equals new scanner data file. Okay, and I'll put a comment after I import scanner. Scanner is a very nice class. I also need a try catch. Scanner is a very nice class. Scanner will allow us to read the data in a file. And again, we saw this last quarter when we did our car example, where we were able to open a file, read data in, and we used both the file class and the scanner class to do this. Okay, so what I'll say now is get the first string out of the file. Okay, so scan file dot next line. Okay, this will just return to us the first string out of the file. String data equals scan file dot next line. So this is going to give us that line of data in the file. And what do we do with it? Well, shoot. I'll tell you what, we need an annuity, employee, or life insurance class. But which one? Shoot. Well, how do we know? Because we're going to need to take this data and pass it to the process method of annuity, life insurance, or employee. But how do we know which one we should hand it off to, annuity, life insurance, or employee? What do you think? There's something inherent in this system that's going to tell us what class should process the file. And that is the file name. Take a look, it's right there. Annuity, employee, and life insurance. If we can only pull that out of the file name and then pass it to a factory method, it's going to make our life very easy. Okay, let's give it a try. So let's say before we even get to scanner, let's say string file name equals data file dot get name. Okay, now if we have a file name, it's going to be annuity underscore blah 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 dot text. All we're interested in is the part before the underscore. So how do we get that out if we have a string? Again, go back to last quarter and think about substring. I can easily find the location of the underscore in the file name. Okay? Int underscore location equals file name dot index of, remember that guy? And then pass in an underscore. Okay, let me move this over so we can try and get as much of this on the screen as we can. See that? Okay. Now, using that location, get the type of file out of the file name. Okay? File name dot, whoops, dot substring. Okay, remember, begin index where we want to start, inclusive, end index where we want to end, exclusive. And NetBeans was smart enough to figure that out for me. I want the characters in the file name beginning with position 0 and ending right before the underscore. Okay, so we'll say string file type equals file name dot substring 0 comma underscore location. This is going to give me all of the characters in the file name up to and not including that underscore. So what I can do now is I can invoke a factory method that will create the appropriate class to process this data. Okay, so let's make a method called create monthly item. Okay, file type. Okay, now it's going to get mad at me here because that method doesn't exist yet. So I'll say create method, I'll tell it to create it, and there we go. Okay, now remember in driver from our last example, let me see if I can pull that up. There we go, vehicles. And then we had vehicles, and then we had driver. Remember this factory method we made, create car? Let's make something just like that, but we're going to make it for life insurance, annuity, and employee instead. So create monthly item if file type equals ignore case, employee, return new employee. Okay? Open curly, and then finally a close curly. Else, if file type equals ignore case, annuity. Okay? Return new annuity. Okay? Else if file type equals ignore case, life insurance. You see what I'm putting in the if test here is the first characters of each file name before the underscore. Return new life insurance. Okay, now we have the same dilemma that we had back in driver, which is we're getting a red line now because, why? Cannot return a value from a method whose result type is void. So we need to change that return type from void to something else. But what? Let's go back again to our class diagram and remember, what does employee, life insurance, and annuity have in common? Well, they don't have a common superclass, and they should not. They do have a common interface. And remember, an interface can be a variable type. The object inside must implement that interface. All three of these objects implement that interface. So let's go back. Instead of void, let's make it monthly item. And to clean this up a bit, let's make a variable. Let's make the return variable. Monthly item equals null. We'll just start it at null. And then we'll say monthly item equals new employee if it's an employee. Monthly item equals new annuity if it's an annuity. Okay. Monthly item equals new life insurance if it's life insurance. And then finally return monthly item. It's usually a little bit neater to keep the return statement at the bottom. So there we have it. And I choose save. And I come back up here, and here's my call to create monthly item. So what I'll do is I'll say monthly item mi equals create monthly item. Now, what I can do here that's magic is tell the monthly item object to process the data. mi.process data. There we go. Perfect. At this point, our monthly runner is almost complete. We're almost at the 42-minute mark as well. So what I'm going to do is save this, and I just want to prove out what we've done so far. So I'm going to add a breakpoint here on the run method and make sure that we can go in, open the file, get the right file type, okay? After that, we're going to actually implement that process method, which won't be too bad. After that, we're going to see how we can clean up this create monthly item method, which won't be too bad. And after that, we're going to put a little twist into the whole story and see what happens when requirements change. Okay, we'll just debug right now, and then I'll stop this lecture, upload it, and start a new lecture. So I right-click and choose Debug File. Remember, the files are already out there, so we just want to make sure it can get the file, it can find the underscore properly, and then it can calculate the file type properly. That's what our concern is right now. So F8. Okay, here's where the debugger's really nice. I just asked for all of the files that are under input data. Let's look in the debugger and see what we have. We have 5 files, which looks really good. Annuity looks great. Next one is annuity. That looks great. We keep going. File number 2, annuity. File 3, employee. 4, employee. 5, life insurance. Great. So it got the files properly. Let's keep walking. F8. Get the file name. And again, this is where the debugger is really nice. It's going to be tricky to get this all on one screen. But you see the file name for the first file is annuity underscore 0123.txt. Find the underscore location. Underscore is at location 7. So 0, 1, 2, 3, 4, 5, 6, 7 looks about right. Okay? So now get the file type. File type should be everything from the 0 character to the 7 character, including the 0 character, but not the 7 character. How'd we do? Okay, for file type, we got annuity. We're looking great. Annuity is a string. We can pass it to our create monthly item factory method. I press F7. We step in. Do we have an employee? No. Do we have an annuity? Yes. We create that annuity, pass it back. We have it now in the variable mi. If I scroll up a little bit more, I'm running low on real estate here. Mi is a variable of type annuity. Looking great. Read a line from a file, store it in a variable called data. There's our data, Phil Smith 1200. Pass this to the process method of annuity. Okay. This is only here because we didn't implement that method. But beyond that, things are looking great. So I'm going to go ahead and stop this lecture now, And when we come back, we're going to go ahead and implement each of those methods. And then we're going to clean the program up a little bit, and then we're going to see what happens when requirements change.